Good morning everybody and welcome to class number 13. In class number 12 we have already discussed what the electric field, different types of electric field, that means electric field at any point or superposition of electric field. And one point I have already told, the electric field inside the charge conductor is zero. I will recall today also. So electric field inside charge conductor is zero. Listen. Suppose the conductor, you will look the cross sectional, you just look as a circle. Listen, तो सर्कल कंडक्टर ऐसा है, ऐसे तरफ से देखो तो सर्कल ही दिख जाएगा, ठीक है. सो तो कंडक्टर, suppose it's the positive charge means there is protons are available. Suppose 4 protons, suppose there are number of protons are available, but we have to think the 4 number of protons. Suppose 4 number of protons. Due to this charge, field direction is what? Field direction इधर भी होता है, इधर भी होता है, इधर भी होता है, इधर होता है, all in direction. Listen. But due to this charge, field is at this point is what? In which direction? That means in line joining two charge. Due to this charge, field is at this point is in this direction. Listen. Due to this charge, field direction is in this direction. That means we have to line joining. We have to think in between two charges. Suppose this point here. At this point, due to this charge is this direction. This point, due to this direction, suppose the Q, same charge. Charge conductor consists of, suppose, number of protons. That means protons are similar size, mass is same, charge also be same, 1.6 × 10⁻19. That means they are identical in nature. Suppose this is the proton, this is the charge, 1.6 × 10⁻19. Suppose due to this charge is this direction, due to the charge is at this point is this direction. That means due to this charge is electric field is this direction. Due to that is this direction. Suppose at this point, middle the point, this electric field is the opposite direction. That means cancel each other. Listen. Similarly, we have to think every proton, this proton, the inside field is zero, because due to this charge particle at this point field is in this direction. Due to charge particle at this point field is this direction. Electric field opposite direction. We already know the proton is the positive charge. Due to positive charge, electric field is outward direction. Yes or no? Negative charge, due to negative charge in inward direction. Yes or no? So similarly, due to this charge, this electric field, due to this charge at this point field is this direction. At this point, due to this charge, this direction. In all are protons. If there is the number of protons are available, we have to consider the number of protons are available. But every protons have electric field, but in this type of electric field direction? Yes or no? Every proton has electric field, but total electric field inside the charge conductor is zero, because due to electric field created by proton, due to created of electric field inside the charge conductor is cancel each other. Example, in this case, due to this charge, field direction is at this point is this direction. Due to this charge, electric field is direction is this charge. That means, suppose we have to think this two proton do cancel, two electric fields cancel each other. Similarly, in charge conductor, number of protons are there, number of charge particle, number of protons are there, but different types of direction are available, but electric field, each electric field opposite direction cancel each other. So that's why the inside the charge conductor, the electric field is always zero due to this concept. Yes or no? Another concept is available. You can imagine. Another concept is, suppose the charge conductor, suppose 4 electrons or 4 protons are. This is the positive charge. You have to think. Suppose the positive charge protons are available, but we have already known the charge particle atom consists of neutron, electron, proton. But charge particle, suppose we have to think, we think the protons are available, but inside the proton the charge particle is charge particle. But always you have to think, always you have to remember the inside the proton, between distance between two protons is always less than 10 to the power minus 15 meters. 10 to the power minus 15 means 1 Fermi. So that means every charge particle, consider very small distance. The charge particle, distance between the charge particle is very small, that is equal to 10 to the power minus 15 meter, that is 1 Fermi. This is the limitation of Coulomb force. Whenever we have already known, it already discussed in class 12. Not 12, in previous class. Whenever the distance between two charge particle is less than 10 to the power minus 15 meter, then they are not active of Coulomb force. That means there is not available of force due to each charge. That means this is the positive, this is the point charge. Suppose the direction is less than 10 to the power minus 15 meter, but the force ड्यू टू चार्ज फोर्स आ रहा है, इधर आ रहा है, अगर सेम चार्ज होता है तो, बट there is no force is active because the distance between 10 to the power minus 15 meter, this is the limitation of Coulomb's law or Coulomb force. Whenever distance between two charge the less than 10 to the power 15 meter, there is no active of Coulomb force. That means the Coulomb force active नहीं हो रहा है, because whenever distance 10 to the power 15 meter को कम होता है, force नहीं आ रहा है. Force नहीं आ रहा है means force is equal to 0. That means you have known force whenever field is available, and any charge placed in that field, then the force act on this charge. That is the F is equal to QE. Whenever force is 0, E almost 0. So that's why it is the another concept. Whenever charge conductor, the every charge particle is the very small distance, there is Coulomb force not applicable inside the charge conductor. There is no Coulomb force. Already you have to think what? The electric field is 0. So it is another method. Yes or no? Suppose yes or no? So then it is the concept, very important concept. Then we have to start the another another topic, that means last topic we have already discussed the superposition of electric field. Then after about electric field, you have to note down electric field or electric field intensity or electric field strength. ये सुन, जो भी लिखेगा चलेगा, ठीक है. इलेक्ट्रिक फील्ड इन ऑल डिस्ट्रीब्यूशन that means we have already known due to superposition of electric field, that means E vector is equal to E1 vector plus E2 vector plus E3 vector En vector. In all direction you have to find out the electric field. The E vector is equal to EL vector plus, I will discuss EL vector plus ES vector plus EV vector. EL means electric field due to linear charge distribution. You have already known E is equal to beta Q by R square. But EL is what? EL is beta Q. You have to you remember Q charge is linear charge distribution. What? Lambda is equal to dq by dl. dq is equal to lambda dl. Q is equal to integration of lambda dl. Yes or no? So instead of Q we can write beta integration lambda dl by r square. Yes or no? And EL is equal to beta integration of lambda dl by r square. So EL is equal to beta dl by r square. Yes or no? You have to remember vector is what? R unit vector is multiplied. Yes or no? Similarly ES means surface charge distribution. That means beta integration of what? Sigma ds by r square, so r unit vector. Yes or no? Similarly EV volumetric charge distribution, beta rho dv by r square, r unit vector. You have already known. This is the point in electric field in all directions. Yes or no? So you can write suppose some notes you can write. First point, whenever electric field is available, whenever some charge Q of mass m, placed inside the electric field, the electric field is here. Suppose the positive charge particle is here. क्या होगा? इलेक्ट्रिक फील्ड इधर है, पॉजिटिव चार्ज इधर है. We have already known whenever charge particle placed inside the electric field, the force act on this charge. Force act on this charge. Yes or no? But direction of field is in which direction? That means we have already known the direction of field is equal to same direction with direction of field. That means the direction of field is same with direction of force. That means electric field we have already known the positive charge यहाँ पे force पढ़ रहे हैं फोर्स कहाँ पे होता है, यहाँ पे होता है किस डायरेक्शन में, इस डायरेक्शन में, इस डायरेक्शन में फोर्स होगा. दैट मीन्स दैट इज द फील्ड डायरेक्शन, दैट इज द फील्ड डायरेक्शन, दैट इज द फोर्स डायरेक्शन, एंड फोर्स फील्ड इन द सेम डायरेक्शन. सो द फोर्स any positive charge mass, it has some mass m, it has some mass m, force F inside placed inside the electric field. but क्या होता है, रिजल्ट क्या होता है, फोर्स आ रहा है तो क्या होता है, इट्स ट्राई टू मूव. दैट मीन्स force is equal to, we have already known Coulomb's force, F is equal to QE. Due to laws of motion, the second law of motion, F is equal to ma, चल QE. सो एक्सीलरेशन क्या होता है, QE by m. Yes or no? So whenever a charged particle having mass m is placed inside the electric field, then this charged particle is try to move in which direction? In which direction? In direction of electric field. So move in this the electric field. Then it has some acceleration. Acceleration क्या है? Initial position it has speed is zero. But after placing inside the electric field, then velocity is occurs. That means some acceleration is occurs. That means A is equal to QE by M. Yes or no? You have to remember. Then you have to think. You have to think. Start from rest. Start from rest. That means U is equal to 0. That means V is equal to U plus at T. We have already known in first year class. V is equal to A. A means QE by M. You can write this expression. Velocity is what? QE by M. Yes or no? Another point are available. So you can note whenever फिगर नहीं करना है, जो बिफोर टाइम जो फिगर कर रहा है ना वो फिगर, ठीक है. तो पॉजिटिव चार्ज प्लेस्ड इन द इलेक्ट्रिक फील्ड, द फोर्स दिस डायरेक्शन इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. दैट मीन्स it whenever a positive charge placed in a electric field, then the charged particle having mass is accelerated. That means the mass particle is, you can note down first point, mass particle is accelerated. This one. The second point, suppose second point, negative charge having mass m, negative charge q having mass m placed in field E. क्या होता है, तो इलेक्ट्रिक फील्ड नेगेटिव चार्ज, तो फोर्स कहां पे होता है, फोर्स उधर होता है. ये सुन, दैट मीन्स whenever positive charge placed in electric field, the direction of force is same with the direction of field. But in negative charge placed in electric field, the direction of force is opposite direction to electric field. So the force is here. So but whenever initial velocity, suppose इधर some initial velocity उधर है, ये सुन, suppose the charge particle, the initial velocity in this direction. Initial velocity in this direction. That means avoid कूलम फोर्स को छोड़ दो, उसका फोर्स है उधर है. जब हम फोर्स दे रहे हैं ड्यू टू लॉज ऑफ मोशन हम फोर्स दे रहा है दिस डायरेक्शन, बट कूलम्ब फोर्स ड्यू टू कूलम्ब फोर्स इज इक्वल टू एफ इज इक्वल टू क्यू ई, दिस फोर्स इन दिस डायरेक्शन, but it tried to rest. Initially it has some force, that means it has some velocity in this direction. After the applying the coulomb force in this direction, that means it tried to rest position, that means initial position it has velocity is u, after then velocity is decreases, that means it is tried to deceleration. So you can write for negative charge its velocity decreases, its velocity decreasing, the time of motion retardation. Listen, you can write this is the point.